So you've got this brilliant idea for a gadget, right? But how do you actually make it work? Today, we're digging into the two tiny brains that can bring your ideas to life, Raspberry Pi and Arduino. And trust me, picking the right one from the start is absolutely crucial. So let's start with your idea, because choosing the right tool from the get-go saves you time, money, and a whole lot of frustration. Whether you want to build a smart gadget for your house or a sensor for a science project, the brain you choose makes all the difference. At a glance, yeah, they kind of look like cousins, right? Just two small circuit boards with a bunch of pins sticking out. But don't let that fool you. These two have totally different ways of getting things done. And this right here, this is the whole game. It's really that simple. A Raspberry Pi is a complete tiny computer. An Arduino is a microcontroller, and it's built to do one specific job really, really well. This isn't just some minor detail. It's the key that unlocks which one is perfect for your project. Okay, let's really dive into this. We're going to do a head-to-head comparison and break down what actually sets them apart, from their operating systems to the kinds of jobs they were born to do. Let's break this down. The Raspberry Pi is a tiny computer. Just like your laptop, it runs a full operating system, usually Linux. That means it can multitask, juggle different programs all at once. The Arduino? Totally different beast. It's a microcontroller, so there's no OS. It runs one single piece of code directly on the hardware, what engineers call running on bare metal. This makes it incredibly focused and predictable. I love this analogy. The Pi is the thinking brain, great for complex thoughts, while the Arduino is the reflex brain, reacting instantly and reliably every single time. But no matter which one you choose, they both talk to the physical world using this simple three-step dance. First, an input from a sensor, like a temperature reading, gets sent to the brain. Then, the brain processes that info based on the code you wrote. And finally, it creates an output through an actuator, like turning on a fan. Input, process, output. That's the core of all physical computing. Simple as that. Okay, theory is great, but let's see how this all plays out in the real world. Looking at actual projects makes the difference between these two crystal clear. So get this, for the BBC's Spring Watch program, a team needed to monitor a bird box way out in a remote field. This wasn't just about turning a light on. It involved logging data, tracking weather, and getting remote access. A perfect job for a tiny computer. Their setup was pretty clever. They used a Raspberry Pi to manage two infrared sensors, logging every single time a bird entered or left the box. But here's the genius part. They also added a weather station and a 3G dongle, basically a tiny cell modem, which gave the Pi its own internet connection. This meant it could send all that rich data back to the researchers in real time. And this just brilliantly shows off the Pi's power. It wasn't just collecting data, it was processing it, combining it with weather info, and making it all accessible from anywhere in the world. They could even update the code remotely. That's the power of having a full computer in such a tiny package. Now let's switch gears and look at Arduino. It absolutely excels where instant, reliable response is critical. Because it doesn't have an operating system to slow it down, it's the champion of tasks that need to happen immediately and without fail. I mean, think about an LED tie that has to flash perfectly in sync with music, or a garage door that must open the second you send the command. For these projects, you don't need a web browser. You need rock-solid, predictable performance. The Arduino runs its one program perfectly every single time. That's its superpower. But here's a pro tip for you. These two aren't always rivals. In a lot of professional and really complex projects, they're actually collaborators. They're a team, with each one playing to its unique strengths. Take the Hextoskin smart shirts, for example. They're used in serious health and sports research. And these things need to do two very different jobs at once. They have to accurately measure biological signals in real time, and they have to analyze and store all that complex data. This is a perfect partnership. You've got the Arduino class microcontroller handling the critical, real-time sensing of your heart and breathing rates, where precise timing is everything. Then it passes that data over to a computer, like a Raspberry Pi, which does all the heavy lifting, storing the data, visualizing it, and uploading it to the cloud for analysis. Teamwork makes the dream work, right? This whole idea of using the right tool for the job leads to something incredibly important: designing for reliability. So let's look at a cautionary tale from a remote weather station in Nunavut to see what happens when a project isn't built to handle failure. Imagine this. A huge storm is rolling in, the most critical time to be collecting weather data. But as the temperature dropped, the battery voltage sagged and the sensors started to glitch out. The whole program just froze. The device went offline, and that priceless stream of data was lost forever. So, how could this have been prevented? Well, this failure teaches us a huge lesson. A robust design needs a backup plan. First, you add a watchdog timer. Think of it as a separate little brain that notices if the main one freezes up and gives it a reboot. Second, you always save data locally to an SD card before trying to send it over the internet. That way, if the connection fails, the data is safe. And finally, your code needs to be smart enough to ignore weird, glitchy readings from the sensors. See, reliability isn't about hoping for the best, it's about planning for the worst. And understanding how to build reliable systems like this, well, that's not just for hobbyists. That's a skill that can build a career. So here are the 4 key things you should walk away with. The Pi is your mini computer, the Arduino is your go-to hardware controller. They work great together and always designed for reliability. Learning this stuff is like learning a new language, one that's in super high demand. Whether you're interested in building smart devices for the Internet of Things, designing robots, or even monitoring our planet's climate, these are the tools that get the job done. This is a real marketable skill. You have 2 incredibly powerful, low-cost tools at your disposal. And you just need one good idea to start building something amazing. So I'll leave you with this challenge. Look around your world. What's one small thing you could improve, automate, or understand better? Now you know the tools. The only question left is, what are you going to build?